Hi, I'm Alexandru. I'm a computer geek from Romania, and I'm here to talk about computers and about patience. The most fundamental question that anyone should ask is how much you desire and what you actually desire from life. A sculpture can create brooms, but the same sculpture can create also Stradivarius. Both are sculptures. The difference between those two sculptures is actually their passion and their motivation and time spent in order to succeed in life. An inventor, until he invents something amazing, has to reinvent the wheel a few dozen times. I still need to invent the wheel a few times in order to become an inventor. But as Edison said, nobody's born with knowledge. And the most important stuff is actually there is a natural way to go from simple to complex. I've never seen a researcher who actually said, let's do teleportation. He actually started from something basic, and after that, after many years of research, and after many years of experience, he got different knowledge in order to do his stuff. The greatest advantage of IT industry is that it is able to create a need from a necessary, from an opportunity. For example, many devices that actually didn't really exist about 20 years ago, like laptops, like mobile phones, now there are some needs in our life. For example, this is a picture from Vatican in 2005 and 2013. And you can see that most of the people in 2005 of the Vatican election, they were not using smartphones or tablets. They didn't really exist over there. Maybe there were a few, 2 or 3 tablets. But in 2013, everybody was using mobile phones, smartphones. The world is changing a lot. I was born in Heckelville, actually, and until last year, I was doing my computer science projects over there. I have an experience of 10 years of programming. I've been involved in 40, 50 different projects. I've been to 130 national competition, and I'm going to talk about a few of my challenges. I challenged myself when I was 7th class grade to create my own antivirus. I knew that I will not be able to create a very successful antivirus and to earn some money, because there are a lot of famous companies who spend dozens of millions of dollars in their product, and they've been working a few thousand of programmers with their software. And I knew that I will not be able to sell it. But it was a very great challenge for me to learn a lot of stuff. And I learned a lot from that project. I challenged myself to learn something, and it was an amazing experience. I was able to learn a lot of antiviruses. When I got in the college, I was qualified to attend my first international science fair. So I downloaded the list of the contest projects from the last years, and mostly I was not able to read the project names because they were using artificial intelligence, and they were very complex for me. So I decided to challenge myself to build my own artificial intelligence software. So I built this rapid application development to help programmers and software engineers to create their own software, artificial intelligence software, using my software, my program. So over here, I was making speech recognition, I was making face recognition, neural networks, and was building genetic algorithms, and it was able to export a dynamic library. With that small project and that small challenge of myself, I was invited to the ACM Turing Award ceremony, which is the Nobel Prize in computer science. Of course, I didn't win the Nobel Prize in computer science. I hope so, maybe in 20, 30 years. And it was an amazing experience. There were 12 people over there, and I was a freshman high school student, and there were only PhD people and the people who actually build computer science and engineering. I did also software to recognize, burglars who, when they come to a bank or something like that. It was an interesting experience. So I did a software that uses artificial intelligence. So I challenged myself if I'm able to create my own programming language for artificial intelligence. So over here, I was not really focused on neural networks. I was using fuzzy techniques, genetic algorithms, neural networks, multiple types of neural networks. I was using many different paradigms of artificial intelligence, and it was a very successful thing. It was, I think, my most complex project, and I learned a lot from that software. Although I'm the only user of my own programming language. But actually, on all of my other projects, I was using my own programming language because it saves me a lot. When I was 11, a junior, I have an uncle which is blind. So I decided to create a device or something like that to help him. And initially, I was trying to use a 3D radar and using headphones to send like an audio signal to the headphones to the blind people about the environment. But I found that the ears are bidimensional, so I was not able to use the ears. So I decided to use something different. So I was trying to use the tongue and to send electrical images on the tongue in the idea that blind people, they will try to understand, learn, and recognize objects using their tongue. And that was the sensory matrix on the tongue, and it was placed above the tongue, and the blind people were receiving pokes, electrical images made by pokes, and in time the blind people were able to learn. I tested with my blind uncle, and in 1 month he was able to learn about 40, 50 different objects and to recognize. With that project, also my first or second electrical engineer project, I won a scholarship to study in US for any college I want, and it was the IEEE Presidential Scholarship for $40,000. And also I met the president of IEEE. I made a software to recognize, disasters from satellite maps. But mostly there were challenges in order to learn something. And I was not really focusing, to sell my projects or, to do something with them, to make advertise, to make people know about my projects. When I was senior, I started to study 2 online courses made by Stanford University professor Sebastian Tran about self-driving cars, who actually built Google self-driving car at Stanford University. I was amazed that the Google self-driving car drove by itself about 100,000 miles without any accident. So I decided to challenge myself if I would be able to create 1% of my own self-driving car. And, I was working in my homemade laboratory of electronics over there. I was, coding a lot of stuff over there. And I was, in a few weeks, I was able to create about 1% of my self-driving car, but after weeks, I got 5, 10, 20, and so on. I was able to create, the software to recognize traffic scenes, traffic lanes, and so on. That's a very short movie, simulation of how my self-driving car thinks. It doesn't drive. Actually, it is able to recognize a lot of data, like traffic lanes, sidewalks. It is able to calculate what is the direction of the self-driving car, in which direction should change the steering wheel. That is the Gaussian function. Over here, there are objects detected by my 3D Lidar. Actually, the biggest challenge for self-driving car, at least for the most, are that they are very expensive. They are very expensive because they use a very expensive device. In order to recognize the environment, they use a 3D Lidar. The 3D Lidar is like a radar, but it's mostly based on lasers. On the course, they wrote something like, you just buy your 3D Lidar, place on your self-driving car, and it works. Yeah, the biggest problem was I found that it's very expensive. It cost about $75,000. Initially, I started to look on eBay to buy the 3D Lidar, and I was not able to find on eBay. And then I searched on Google, and I found the price. I closed the browser because I thought maybe something wrong with my laptop. And I just found that it's very expensive. So these are a few self-driving cars who actually use the Velodin, the only 3D Lidar that is very good for self-driving cars. You can see the Google self-driving car, the Volkswagen, General Motors, BMW, Ford, Lexus. They use the same, very expensive. Actually, Sebastian Tran, the professor from Stanford, sent me an email that he actually didn't know how expensive is the 3D Lidar, because the Stanford didn't buy the 3D Lidar, they received the 3D Lidar from donations. Okay, so I used multiple laptops. There were about 5 different laptops in the self-driving car. There was also a driver. It didn't drive itself because I couldn't do that in Romania. I was recording the data from 3 different cameras, from my own 3D Lidar. I was using also a GPS inside, and I was processing all of those data with 5 different laptops because I was not able to buy a very, a very powerful computer with multiple CPUs, so I was just using the maker stuff, many laptops. And I was doing my software over there, and after a few months, I was able to recognize a lot of stuff. But the biggest challenge was actually 3D Lidar, because I was thinking initially to do a different approach, to use image processing to recognize vehicles. But the biggest challenge for that one is that artificial intelligence is not able to work 100%. So in 1 year, there will be maybe a few millions of cars that cannot be recognized using images. But obstacles are everything, not just vehicles. So I decided to build my own, my homemade laboratory over there, to build my own 3D LiDAR, to research about 3D LiDARs. And I did a small prototype of my 3D LiDAR. And it cost about $200, but it's not as good as performant as the Velodin 3D LiDAR. It is only about 18% as the resolution of the Velodin 3D LiDAR, but for me it was a great achievement. I used this the device was able to recognize, buildings even from 100 meters. But humans, it was able to recognize with 100%, only the objects, the humans that are close to 20 meters. So I need to increase the resolution of the 3D LiDAR. But the biggest challenge for a maker is actually to turn a prototype into an industrial product. That was also my biggest challenge. So that's my father car and my 3D LiDAR over there. There were about 5 different laptops inside, 3 different cameras, 1 GPS, and 2 guys inside over there to analyze the data. I recorded about 30 different hours of simulation in my city in Hackerville, how the system works, and I was very surprised that mostly it works. And that's the software which received the data from the 3D LiDAR. Actually, this is a screenshot from the software that uses OpenGL to represent the 3D data. Each object over there, each cube, there is an obstacle detected by the device. And the clusters are actually objects. The 4 clusters around the car are 4 different cars. And on the left and right side, the clusters are buildings from the environment, the blocks, the huge buildings. Because I was using multiple laptops, I needed also to make a supervised software because it was quite hard to open 5 different laptops and to change all of the parameters. So I did a software and to have a master laptop in order to control other laptops. So I did also this software. And with my Lidar Science Fair project, I went to a contest in US, and I talked about my project, how the stuff works behind, how to different professors, and to my surprise, I won $75,000 in US with my project, and I was amazed. I'm still working through the project, but I still have some challenges. But the most important for me was something different. Everybody in Romania, they told me that you should go to US to study over there. Also, I got a scholarship. And you don't have any future in Romania, there is absolutely no possibility for you. And I was amazed that I was able to change a little bit Romania and to do something positive in my country. After I just came, 3 days after I came from US with that award, I talked with the Prime Minister, so I talked before with the Minister of Education, and I told them they should create a scholarship program for teenagers, especially freshmen and sophomore college students, who are really interested in doing science projects and, to work to a project and to earn some money. And there are a lot of money, actually. So they decided to create 50 scholarships, because Romania is a small country, for 15,000 euros each, for, computer geeks who actually build the software or something like that, for Romanian students. Initially, they called Ionut Budisteanu scholarships, but they changed it a little bit after. So I was very proud that I was able to change something positive in my country. And Romania gave me a lot of opportunity, and I can tell you that it is a great opportunity if you are a computer geek. Everybody wants computer geeks. Yeah, for sure. So all of those projects were made by me in order to learn something, and not really interesting to sell, because I'm a 20-year-old guy. So I said, just focusing on learning, or so I want to become a university professor to do research and so on. So 2 months ago, I'd been to a contest in Shanghai, in China, and I met some old friends from China, and I was amazed that, since 5 years, they got very successful businessmen in computers, and they got very successful Kickstarter campaigns. So they made me to challenge myself in order to create my very first, Kickstarter campaign. So right now, I'm working to a machine that also helps my self-driving car. The machine, it is a robot, which helps makers to turn their prototypes into industrial products. Makers, electrical engineers, electrical hackers, hobbyists, they do a prototype. But after that, they need to buy very expensive robots, machines that create, my smartphone from my pocket. The advantage of those very expensive, that cost a few $100,000 robots, pick-and-place machines, is that they create a few millions of products in a month or something like that. But it's not affordable for makers. So the second option is actually to go to factories, like German factories or like Chinese factories, to give your prototype, and after that you'll just receive a few samples. But mostly they will refuse you because they are looking for big companies and not for makers. So I'm looking to finish VisionBot, pick and place machine, which is a low professional but low quantity or medium quantity for startups projects in electrical engineers, for makers like me to turn their prototype into industrial products. So I'm trying to use my VisionBot after that to create my projects into a industrial scale and to make a mass production of my 3D Lidar or the human-computer interface to help blind people to see their tongue and many other devices that I've been working. So right now I'm just working to the machine, and in a few months I hope I'll find the first customers, the first makers who want to buy the VisionBot in order to use it to help to make their projects. So thank you very much for this attention, and I want only to tell you that you are the world's leaders. It's only about passion and motivation. Just focusing on your passion to do whatever you like, and you will be very successful. Thank you very much. Thank you.
So, Ionut, you're 20 now. How old were you when you built your self-driving car?
19.
Okay, and you come from the town in Romania that's notorious for being the place the criminal gangs hack the world, known as Hackerville.
Yeah, it is called the cybercrime capital of the world, but mostly it was made by media because everybody was saying over there, all of the media, international press, like French Le Monde or something like that, that people in my city, they do hack. And everybody was asking me and other people, it's quite an easy job to do that stuff, and they learn from internet, they learn from YouTube or something like that to do hacking. But I was amazed, but after I got the Grand Award in US and I've been able to motivate a lot of people in my town, and I heard in my neighborhood from Hackerville, the kids, they were not playing like, to become the next Kevin Mitnick who hack international agencies, and they want to be like the next maker to change the world.
So I'm wondering what your parents got wrong. How come you became an inventor? No, what was it about your upbringing that you think made you bold enough to try what everybody here would see as an almost impossible project?
No, the idea was, go from simple to complex. I have 10 years of experience behind. I've been to 100 international competitions in Romania about computer science, about inventions, about electrical projects. So, nobody's born with knowledge. So Edison said, 90% working and only 1%, inspired. So in Romania, actually why I choose to study furthermore in Romania is that Romania became, in 20 years, the country with the most experts in IT from Europe. 20 years ago, most of Romanians have never seen a computer. But media in Romania was able to promote computer science. And all of the magazines, they just said, a few geeks, computer geeks who did a $1 million company or something like that. And they told that computer science is a very simple job. So they changed Romania to become a very successful country in programming. And Romania became the 5th country in the world with the most experts in IT because it's a little bit hard to compare Romania with China. 1 billion people to 20 million people, so most experts in China. So, Romania is a very powerful country in computer science, and this is why I decided to study furthermore in Romania and to don't go to study at the US colleges.
Ionut, what do you want to do when you grow up?
Yeah, I know. I want to become a university professor because actually who changed the world are the university professors in IT. I mean, 50 years ago, most computer science didn't really exist, and there were a few professors in different colleges and different universities who did research, and all of those devices that we have over here that are very great were designed and theoretically made by these professors. And after that, a few companies, like big companies, they did applications. So I want also to become a university professor and to inspire other people to become the next makers.
Well, thank you.
Thank you very much.
Ionut Budisteanu.